Hi all, this is a very interesting task anyway to me. This is about the new technology of the power tools. So if you have come to this video, so you've probably seen this kind of batteries that is written 18 volt and 54 volt. So I was asking myself, how come this battery can output 18 volt and on other tools it can also output 54 volts. So I was searching how they did it, and I tried to understand how they are doing it with DC to DC. Maybe the battery is changing the voltage, but it seems much more simple than you think. And after doing some reverse engineering, I've seen someone that taking this battery, disassemble it. I didn't disassemble, I don't have such a batteries, but I was interested to know how it works. So I will show you how it works. This battery can output 18 volt and on other tools it can output 54 volt. First of all, why do we need it? So in the power tools, it's a simple basic rule of power in electrical engineering. If you want to deliver the same power, so for example you can do it with, let's say, 54 volt and deliver 3 amp, and the power out will be 54 multiplied by 3, 150 plus 12, so it will be 162 watt. Yeah, but you can also deliver the same power output by doing this, using just 18 volt, but instead of 3 amp you will deliver 9 amp. Yeah, so basically what you're doing is changing the order of the cells. If it is more cells that is connected in parallel or less cells, but why do we need it? So this will be exactly the same number. Yeah, it will be, let's do the math, it will be 90 plus 72, so it is exactly 162 watt, 162 watt. We need it because if we want to deliver 9 amp, then we need much wider wire in order to have less power loss on our copper wire, because if the copper wire is very thin, so the voltage on the copper is much more. If we're using this kind of wire, let's call it the thin wire, or we take wire that is 3 times wider, so, and we deliver the same power on this wire, we will have much less loss. For example, let's say we have a loss of 1 volt on this wire. This is just an example. So on this one that is 3 times wider, we will have loss of 1/3 volt. So basically we have less loss when the wire is very thick. But if we will take a higher voltage, then we can use much thinner wire in order to deliver the same power out. So if we will go to higher voltage, we can use thinner wire and we will have much more power for the load. Now let's see how it works. This is just an assumption. I'm not sure about it, but I think that they are doing it this way. Okay, just a second, I will zoom so we'll be able to see everything. So this is how I think that this way is working. I think that it is mechanical, so there are no MOSFET doing it, no DC to DC, just connection between batteries. So how they are doing it? So if we work with the 18 volt, so I think that when they disassemble the batteries, they have positive connected to negative, positive connected to negative, positive connected to negative, positive connected to negative. This, of course, each one is individual cell with positive and negative side, and the negative is connected to the positive of the other battery, and this is how it goes. So we have 5 cells. Also we have on this side same connection, and the last side we have this connection. Now if we are going for the 18 volt, so in the 18 volt we have all the cells connected like I'm showing now. So let's use, for example, other color. We will take maybe a green one. Okay, so if we are working on the 18 volt, so what the battery is doing, it has a physical connection between this and this, like this. All these parts are connected together, which lead to 3 cells in parallel for each individual of the 15 cells. So we have everything is connected in parallel. So basically we can call it a 3 in parallel and 5 in serial. So we have 3 P5 serial batteries. And this way, if for example each battery is 3 amp hour, so the total will be 9 amp hour. So we will have 18 volt with 9 amp hour. 9 amp hour. This is the 18 volt. Now when you convert it to 54 volt, something going on, and I will show you what is going on. This is what I think. I am not sure, but I think this is the only way to do it. So what is going on when you use on the other way? All the green connection are disconnected, mechanical. So not connected, not connected, not connected. We remove all these connections that I've explained, but we still have the blue wires that is connected between the cell in parallel. Now we disconnect all this connection and we add 2 major connection. One is going from this negative of the 5 first column cells to the positive of this cell, and we have this negative of this cell is going to the positive of these cells. And now our output is this side and this side. So we have from this side on the top to the bottom side here we have the 54 volt, but now we have 54 volt and only 3 amp. The total power of the battery is the same. Or we have 18 volt 9 amp hour battery, or we have 54 volt 3 amp hour. If we will multiply this 18 with 9 or 54 with 3, we have the same total capacity power of the battery. Okay, so total power of the battery, a watt hour, what we call watt hour. So we have the same watt hour if we 18 volt with 9 amp, or we have 40 volt 54 volt with 3 amp. We have the same power watt hour battery. So this is how it works. I'm almost sure that this is the way these batteries work. And yeah, this is my reverse engineering. Hope you enjoy. Thank you and bye.